Welcome to qnawire.
Hi, so over here we're asked to calculate the pH of a 0.001 molar solution of formic acid given the value for Ka. So the reaction that we're going to be considering is going to be directly that of HCO2H plus water in order to produce H3O plus HCO2 minus. Over here everything is going to be in aqueous solution except for the water, which is going to correspond to a liquid. Recall that in these scenarios, water is not going to enter into our equilibrium equations when we consider the ice table. So water, we can disregard it. We're going to have an initial concentration of C0, 0, and 0, and a function of change minus x, and plus x. So that the equilibrium, we're going to get C0 minus x, and x. So with this, we can calculate what is going to be the pH of the solution by solving for x, since x is going to be equal to the concentration of H3O that we will get at the equilibrium. Thus Ka, which is going to be equal to concentration of H3O times concentration of HCO2 minus divided by the concentration of the weak acid HCO2H, becomes x squared divided by C0 minus x. Now over here, since the value for Ka is going to be small, we can approximate this as considering that x is going to be much smaller than C0, thus C0 minus x is approximately C0. Thus, we're going to get x squared over C0. Solving for x, this would be equal to the square root of the value for Ka times the initial concentration. In this case, for us, the value for Ka is 1.7 times 10 to the minus 4, and the initial concentration is going to be equal to 0.0010 molar. So, doing this operation, we're going to find that the value for x, which as we mentioned was the concentration of H2O+, would be equal to 4.123106 times 10 to the minus 4, which corresponds to a pH, which is the minus logarithm of the concentration of H2O+, equal to 3.385. And over here, this result, you can actually plug in the full value of the concentration to get more significant digits, or in this case, you can cut up to the number of significant digits appropriate by the problem. So in this case, all of the quantities given are up to 2 significant figures. As you can see, 2 significant figures and 2 significant figures. So that means that the pH that we should report should have as well 2 significant figures, which is 3.4. And with that, it would be all. Thank you very much and have a good one.